We look up at the night sky and see quiet, glowing spheres. Generations have dreamed of traveling to these distant worlds, imagining them as serene destinations waiting for our arrival. But the human body is a biological machine, calibrated for survival in one highly specific set of environmental conditions. We look at what actually happens when a human being physically sets foot on every world in the solar system. Stepping unprotected onto any other world in our cosmic neighborhood triggers an immediate, catastrophic biological failure. Near the Sun, Mercury lacks any atmospheric buffer. This heavily cratered, scorched surface remains fully exposed to the radiation of the vacuum. Standing in the sunlight, you would ghost at 430 degrees Celsius. Within minutes of stepping into the shadows, the temperature crashes to -180 degrees, cooking and freezing a body in the same afternoon. Moving outward to Venus, the lack of atmosphere is replaced by a massive, suffocating density that changes the method of destruction. Surface pressure on Venus is 92 times that of Earth, the same force as being 900 meters underwater. Combined with 465-degree heat and clouds of sulfuric acid, a human would be crushed and dissolved within seconds. Proximity to the Sun on these inner rocky planets create volatile extremes that instantly overwhelm human temperature and pressure regulation. Mars visually mimics a familiar Earth desert, but the reddish-orange landscape provides a false sense of security. The Martian atmosphere is less than 1% the density of Earth's. In this near vacuum, the boiling point of liquids drops. This triggers a biological condition called embolism, where blood begins to boil at your normal 37-degree body temperature. Within 15 seconds of exposure, the resulting gas bubbles expand and rupture the blood vessels. On Mars, the invisible absence of pressure is as violently lethal as a scorched surface or toxic acid. Past the asteroid belt, the planetary composition shifts. The presence of solid ground disappears. Descending into Jupiter, you would plummet through 620 km/h winds without ever hitting a surface. Saturn's rings hide a similar nightmare. Falling towards its center offers no solid landing, only an endless descent into the core. Extreme atmospheric pressure eventually compresses a human body into a small, dense ball of matter before hitting anything solid. The gas giants present the horror of a prolonged, inescapable descent into a crushing abyss. At the dark outer edges of the solar system lie the ice giants, Uranus and Neptune. Beneath the pale, featureless exterior of Uranus, you would encounter a gauntlet of -224-degree methane ice clouds. Upon contact with these deep space temperatures, the human body flash freezes. Neptune introduces a compounding threat. The solar system's fastest winds, reaching 2100 km/h. These far edges combine extreme cold with supersonic kinetic force to literally tear a frozen body apart. Leaving the suffocating dread of the outer planets, we return to the calm, breathable reality of Earth. The safety of this single globe stands out against the 8 unique methods of instantaneous destruction found elsewhere. Breathable air, stable pressure, and moderate temperatures are nothing but a microscopic statistical anomaly in an incredibly hostile universe. Earth is a rare sanctuary that holds the infinite hostility of the surrounding universe at bay.